So in this video, we are going to do some examples using the T-chart and also using our calculator for not only data entry, but also to solve these t-value problems. So let's go and talk about 10 randomly selected people were asked how long they slept. The average was 7.1 and the standard deviation was 0.78. Find the 95% confidence interval of the mean time. All right, let's put down what we know. Our n is this 10. Our mean was 7.1. So this is going to be our x bar in this case. And our standard deviation was 7.78 hours. So we're going to use a lowercase s, and we're going to do that because our sample size was under 30. Now off to the side here, let's write down our important information. As your math coach, it's probably best to kind of get used to this. So the n, or the sample size, is 10, which means that my degrees of freedom is going to be 9. We need the degrees of freedom to use the t-chart. We also have our x bar, which is 7.1. We have our s, which is our standard deviation, and that is going to be 0.78. We also know from the problem our 95% confidence interval. And so this is going to be a little bit different than what we did on the t-charts because we don't need to do any kind of fun looking at the chart or looking in the center of the chart for the t-chart. My students definitely feel that the t-chart is a lot easier to read than the z-chart. So the confidence interval is 0.95, which means my alpha is 0.05. So what we're going to do is we're going to use the two-tail side of the chart, or part of that row of the chart, when we figure stuff out here. So let's get our t, alpha divided by 2, value. So what do we need for that? Well, we need to know the degrees of freedom. We also need to know our alpha, and for the rest of this work here, we're going to make sure that this is the two-tail. So 9 degrees of freedom, 5% alpha on the two-tail row. So we go to our chart, and we go to 9 degrees of freedom. Now this is from an earlier video here, so let me kind of erase some of this just so it's a little easier. So 9 degrees of freedom, 2 tails, and 0.05. 9 degrees of freedom, 2 tails, 0.05. It looks like my answer is 2.262. All right, so I'm going to write that down and make sure I have it so I can load it into my confidence interval function. 2.262. So my confidence interval function is x bar plus or minus the EBM. And to review from the previous video, my EBM is when you multiply the t alpha divided by 2 by your standard deviation s divided by the square root of the sample size n. Okay, so this is 2.262 times my 0.78 divided by the square root of the sample size, which is 10. Every once in a while, you might make a mistake where you put the degrees of freedom under the square root, but it really should be the sample size. Okay, so that gives you an answer of approximately, and I've done the work already on my calculator, 0.558. So my x bar, let me change colors just so it becomes a little bit cleaner to see here. My x bar is 7.1. Now the 7.1 is our average. Our EBM is the give or the take from that average. So this is plus 0.558 and minus 0.558. So if you're asking about the average sleep time according to these 10 people, and maybe the reason why these 10 people were chosen is they had some significant characteristic that separated them from just getting other people who would normally be able to be put into a sleep study. Maybe their location or their age or something very particular to these 10 people, which required gave such a small sample size. So this 7.1 is the give or take about a half hour of sleep. So if I add the 0.558 to that, I get 7 0.658 hours. And if I subtract that half hour of sleep, I get roughly about 6.542 hours. Then you put this in parentheses, and what I just did in red is my confidence interval. This is the 7.1 hours, give or take a half hour. So I am 95% confident that the sleep cycle of these people, or people similar to these 10, will be between 6.5 and 7.6 hours of sleep. So let's try this on the calculator. Now, so the calculator function is going to be, instead of the z interval, it's going to be, well, I just wrote z. Instead of the z interval, it's going to be the t interval. And this is, again, in the stats menu of the calculator. The format of the t interval, and this is going to be in the stats format, because there's a stats, and as you'll see in the problem below, there's also a data format. In the stats format, you're going to type in your x bar, then you're going to type in your standard deviation of x, then you're going to type in the sample size n, and then your percent, which is your confidence interval. So let's actually look at that on the graphing calculator. So we are going to get to a nice clear screen, and then click on the stat button. Then we're going to move over to tests, and you might have to scroll down a little bit based on the screen of your calculator. So my t interval is at this level, so I'm going to push that 8 button or hit the enter button, and I'm going to switch over to the stats, because you can choose either data or stats. Data is what we're going to use for the next 2 problems, but let's click over to stats since we actually have all the information. So my average here is 7.1. My standard deviation is going to be 0.78. Sample size is 10. And my confidence level is already set at 95%, so that's kind of handy. If it's not set, you just type in 0.95. Click on calculate, and it takes me to this. The answer that is exactly what we got, 6.542 and 7.658. It gives it to you in perfect interval notation, and it has the x bar, it has the standard deviation, and what we entered. So that's pretty nice. It's pretty nice. It does all the work for us, and in case you do have to show your work, I've done that for you in blue and red, and here's the calculator information for getting to the answer through the technology. Now, this data represents the number of home fires started by candles for a few years. Find the 99% confidence interval for the mean number of home fires started by candles each year. Okay, it's important to know what we have, and more importantly to know what we don't have. First of all, we have the sample size. We have the sample size here because it's 1, 2, 3, 4, 5, 6, 7 pieces of data. So we have our degrees of freedom, which is 6. Well, we have our confidence interval, which is kind of nice. Our confidence interval is 99%, which means my alpha is 0.01, and this is going to be 2-tail. And again, confidence intervals are always 2-tail because of a low number and a high number. But here's what we don't have. We don't have x bar, and we also don't have the standard deviation of our x. These are notably missing. So what I'm going to do is I'm going to actually do the calculator step first. And by doing the calculator step first, I can actually go back and show you how to do this by hand using the information from the calculator. So it's kind of a for knowledge sake, but it's pretty great. So here I have the calculator, and I'm going to click on stat, and I'm going to want to enter the stats. So to enter the statistics, or these numbers here, I'm going to click stat and then enter. Now you'll notice I actually have data from a previous problem, or actually literally from the next problem. So if I want to get rid of that data, I would click up once and make sure I'm highlighting the list 1, and you'll notice that it lists all the numbers in set notation. We're going to clear this set by hitting clear and then hit enter. By hitting clear and enter, you do not get rid of your list 1, and it makes this really nice and clean. Now, it is possible to make a mistake, and I showed this in the previous video, to hit delete. Oh no, the list is gone. So you're going to click second and then del, and that inserts a list, and go second and 1 and hit enter, and it brings it back, including maybe some of the sets that you actually entered into it. So let's hit clear and enter and get ready to start to type in this data. So 5460. And you just type in each number one at a time. Whoops, 6090. And you just do one piece of data at a time, and this is so short I can type this in the video and you're not going to get too bored, but there it is. There's my 7 pieces of data. Okay, now what I'm going to do is I'm going to actually use the t-interval shortcut here. So I'm going to go to the stat, I'm going to go to tests, and I'm going to go all the way down to the t-interval so that I can either hit the 8 button or hit the enter button. And now I want to enter the data. Okay, so the data is in list 1. We want the frequency to be 1, which means we want to count only each data piece one time. And then the frequency level, let's look at that. The frequency level, that is going to be 0.99. And then we go to calculate, and this gives us an answer. It does some data. All right, it looks like it goes from 4,785 to 9,297.9. Okay, so let me get that written down here. So my answer to the problem, which I'm going to write down below here, is 4,785 and 9,297.6. All right, that is your 99% confidence interval for the average number of home fires caused by candles each year. You notice it's a pretty wide spread. Partially it's because of the 99%, because as we increase the confidence, we increase the spread, but also because this range of data is small and also has a pretty wide range just in itself. But let's go back to the calculator for a moment and take a look. We have our average now of 7,041.4, and we can put that down. We can also even put our average down here. So this calculation actually gets this for us, and the answer and our sample size, which is pretty nice. So just in case you wanted to do this by hand, I'm going to show you the rest of this problem as if we computed it by hand. This is actually for information purposes, but you can kind of see how the process goes then. Okay, so here's our average, here's our standard deviation. Now these are heavily rounded, which means that actually computing the x bar plus or minus the EBM might actually take us off, whoops, not EMB, EBM, might actually take us off of this calculation error, right, or calculator problem right here, but let's do it out longhand. So the EBM is equal to our, let's compute that. This is going to be equal to the T alpha divided by 2. And in this case, we're going to look up 6 degrees of freedom. 6 degrees of freedom at 0.01 to tail. So we go to our chart, and we're going to go to 6 degrees of freedom. We're going to go to 0.01 on the 2 tail, which takes me to 3.707. Okay, so we have 3.707 as our T alpha divided by 2 times our standard deviation, which is 1,610.3, divided by the square root of the sample size, 7. Now I did this already on my calculator, so this gives me 2,256.2. So this is our give or take. If we start off with our average, and our average was 7,041.4, then this is going to be the give plus 2,256.2, and if I added that up, I'd get 9,297.6. And if I subtract this value here, the 2,256.2 from the 7,041.4, I get 4,785.2, which is, if you compare the red versus black, pretty close. So that's pretty awesome. And so for our last problem, we just have a longer list of data. So it's the same thing as problem number 2, although I did change the confidence interval level because I saw that, oh, we didn't have one at 90%. So let's do a 90% confidence interval level, and in fact, I think it's time for you to pause the video and try it yourself. And once you've tried it yourself, you can unpause the video and see how you did. Okay, so it just so happens that I actually loaded this into the calculator before I got started, so I copied this into list 4. So here's a fun technique. If you ever have data in another column, like you see I have all of this data in column 4, but I want to move it to column 1, you can move your cursor up to list 1, hit second 4, which allows you to bring list 4 into this column here, and hit enter. Please make sure you do it when you're all the way at the top. You can also hit clear and enter, and to show you again, you move up to the very top, click second and click 4, and that just takes, it says list 1 is now equal to list 4, and bloop, there it is. Okay, so let's grab all the important information from our t-interval stat command. So I'm going to click on stat, I'm going to go to tests, I'm going to go down here to the t-interval. Now, we got data, we got the list 1, we got the frequency, except we're changing this to 0.90, please, and you can put a 0 for style, but you might be asking, why would I want to copy down all this data if this is just going to give me the answer? Well, it's possible that my homework problems might ask for different parts of this data, like you might have to calculate the EBM, or you might have to tell me what your degrees of freedom are, and it's a little bit easier for the calculator to count this up instead of you as you type this in. It's easy to make a counting mistake, but you know, if you've double checked your data correctly, your calculator will never miscount. So let's get the information from the calculator. All right, looks like we have an answer of 27.385 and 32.299. I might be rounding these, to be honest, but I also want to throw out this idea that we have our average here, and you may want to write down several decimals here, but I'm only going to write down 1, and this is our average and our standard deviation and our sample size. So keep that calculator handy as we write down the critical information to this problem. So let's get all of that good information right from the calculator. What do we know? We know that our x bar is equal to 29.8. Now, by rounding to 1 decimal, I am not going to be as accurate as the calculator, and sometimes in these shorter rounding steps, you might get a different answer than XYZ homework. So please make sure to try to use as many decimals as possible, but since we've already done the calculator step to get us the interval of 27.39 to 32.3, let's just show you what would happen if you wanted to do this by hand. The standard deviation, capital letter SX, is going to be the 6.2. Now please understand that the capital versus lowercase letter s, they're going to mean the same things. This is the standard deviation you use when you have under 30 pieces of data. Our sample size was 19, which means that my degrees of freedom is 18. The confidence interval for this problem, I changed it to 90%. That means the alpha is going to be 10%. I'll write that as a decimal, so you can look at that on the two-tail portion of our chart. Okay, so let's actually do that. Let's go to the two-tail portion of our chart. Let's go to the t-distribution. Now, since we have to scroll down quite a bit, it might be a good idea if I just kind of lock in which column I'm going to be looking at. So it looks like I'm going to need a two-tail at 0.10, so that's going to be the second column here. I'm going to scroll down to 1 minus the n, which is 18, so that's 1.734. 1.734 across from the 18 and down from the 0.01. This is our t alpha divided by 2. And we need the t alpha divided by 2 because we need to put that into our formula for the EBM. So the EBM is equal to our t alpha divided by 2, which in this case is 1.734, multiplied by the standard deviation, in this case it's 6.2, divided by the square root of the sample size, and the sample size was 19. Common mistake is that sometimes people can accidentally put down the degrees of freedom in the square root, but it's really that value there. And this gives me an answer of 2.466, which is going to be our give or take off of the x bar. So again, our x bar was 29.8, and the standard deviation, I'm sorry, the EBM is the give or take off of this estimate. So here's the give and the take. The give is adding the 2.466 to the 29.8, so that's 32.266. And then the subtraction is the take. So subtract 2.466 from 29.8, you get 27.39. And then this, if you put a comma between them and parentheses, this is your solved by hand interval, which is a little different than the solved on the calculator interval. Whoops, I'm sorry, this would be a 33, not a 39. The 39 came from the calculator, so this is what you would get if you solve for it by hand. And again, the ways to make it a little bit closer to the calculator is not round so much in the standard deviation or the average, but of course the calculator method will, take all 9 or 10 decimals and slap it in there, and it's a pretty good way to do it. So one last comment though, that you have been doing a lot of great homework. I will say that sometimes you might feel like, hey, I think I'm doing the right thing, but XYZ isn't matching my decimal to the fourth or fifth, second decimal. Shoot me an email through XYZ homework and tag the problem, or you can do so in the forums, and I will let you know if that is a mistake on your end just by data entry, or if there's something you're missing. Or I'll just award you the points because there maybe was some rounding error during the random regeneration of the problem. But I appreciate you doing the work, and thank you for watching another video.